Hi, this is Professor Stugard, and in this video, we're going to discuss what is statistics and focus on sampling and bias. Now remember, statistics is our science of collecting data, organizing data, summarizing and analyzing data, so that hopefully we can draw conclusions, answer questions, and do all kinds of interesting stuff, and hopefully gain some more understanding about the world around us. But the first step is to collect that data. And that is a critically important step because typically it's going to be impossible for us to collect all of the possible data for whatever it is we're trying to study. Whether we want to get the opinions of Americans or if I just want to find what is the average salary of a particular profession, it's going to be almost impossible to ask every single person. And even if I were able to ask every single person, it would be impossible to require them to answer me or to answer me truthfully. So no matter what, whenever we're trying to analyze this data, we're only going to be looking at just a small portion of the overall set of data. We're going to rely on just that small part to make our conclusions. So we need to make sure that that small part is a good part. Now, before we get into the rest, let's review some of our definitions that are really, really important. First of all, population refers to the entire group that I want information about. So again, if I want to know how all Americans feel about a particular topic, my population would be all Americans. I know that I can't possibly ask every single American in the entire country, so I need to rely on a sample, and that's my small subset of the people that I ask. And then each person who's a part of my sample is called the individual. So that's the single participant. So we start with our big population. We pick some people out of that population, they represent my sample, and then each part of my sample is composed of the individuals. Okay, now remember when we talk about statistics, a parameter is what describes a population, and a statistic is what describes a sample, which is why this is called statistics, because we're going to be relying on that small sample and trying to draw conclusions from just part of the data. Now, one of the main goals is we want to be able to estimate what that parameter is. We want to estimate the population using our statistic or our sample. And again, because we only have part of the data, we're going to have to include a margin of error based on probability. We'll get to that part eventually, but we're going to focus today on just making sure that that sample is as accurate of a sample as possible. And also just, again, remember, parameter population, the P's, statistics sample, the S's, to help you remember. Now, one of the big problems when we try to collect data for our sample is that sometimes our data might be biased. Now, what is bias? This is a good opportunity to actually take a second, stop, pause the video, think for a second, because I'm sure you've probably heard the word bias somewhere in your day-to-day life. And what was it connected to? What is bias, right? Everyone probably has some prior knowledge. So what do you think? Now, again, if I had a group of people, we might all come up with some different answers. I think one of the more prevalent ones is people talking about prejudice. If we are prejudiced, we are biased. And that's absolutely part of it, right? We have claims that certain industries are biased against races or biased against women, or that means what we're talking about is a prejudice. But it also applies to things where people might be a biased sports fan. So again, I think the Eagles are going to win the Super Bowl this year, but maybe I'm a biased sports fan. And then also shows up a lot with nepotism, where we see people in power giving positions of power to their family members or their friends instead of necessarily people who would have earned it through merit. And again, you can probably come up with some other ones too. Hopefully, again, you're thinking in your head, oh, I've heard biased. What does it mean? Oh, I have some ideas. And again, these are all different ways or different contexts in which we hear it. But typically, we're going to define bias when our sample is not representative of our population. And that does actually apply to some of those other ones as well. Whenever our sample, whenever that small portion is not representative of our population as a whole, we have bias creeping in. Now, when we do our sampling, when we do statistics, our goal is to hopefully gain as much information as possible, but we also need to minimize cost. So again, this will be something we talk about more later on about how do I balance that? How do I get as much information, knowing that I also need to minimize my cost and I can't spend forever collecting my data. At some point I have to analyze it. But because my goal is to minimize that cost while getting as much data as possible, there are ways where my sample might not be so good. Now, one of the first ways that happens is with our sampling bias. And this means that the technique that we used to choose the individuals favors one part of the population over another. Now, this can happen in a couple different ways, but most commonly we see what are called convenience samples. This is when we choose individuals because it's just easy to ask them, and not necessarily because it's random, not necessarily because it represents the entire population, but just because it was easy. And that happens all the time. Now, what happens when that occurs is we end up with undercoverage. And this is when some segments of the population are less likely to be chosen, meaning we don't actually represent their opinions or information or data about them accurately. Now, for example, let's say I want to know how all Americans feel about student loan forgiveness, right? That's a big hot button political topic here. So because I want to know how all Americans feel, I can't ask all Americans, so I need to rely on a small sample. So I'm going to go to the college and I'm going to go survey the people sitting in the student lounge. Would this be a good sample for my particular study? Now, always a good idea. We got to take a step back. So first questions, well, what's my population? Who do I want to study? And like I said, in this case, my population is Americans. I want to know how all Americans feel. So how am I going to choose my sample? What is my sample in this particular study? Well, my sample is going to be the people in the student lounge. Is this going to be a good sample for all Americans? Well, take a second to think, but hopefully we come up with the conclusion that it is probably not, because if people are in a student lounge, that means they're already going to college, which means they will probably be in favor of not having student loans when they finish college. They would probably have a much higher incident of supporting student loan forgiveness than someone else, right? If we went to maybe a local trade group, right, or people who did not go to college but jumped straight into work, and we asked them, hey, do you think your tax dollars should be paying for other people to go to school, some service that you didn't use? Well, they will probably be much less likely to support student loan forgiveness. Now again, some might not. You might even have some students in that student lounge who don't support student loan forgiveness. But the point is that you're not having an accurate representation of all Americans if you're only choosing students in that student lounge. You need to do a much better job of choosing your sample. And again, this is a good one where there's legitimate arguments on both sides for why we should and should not have forgiveness. And it's a great opportunity to hopefully debate and look at different sides of the argument to see how you feel. Now, that's because there's no right answer to this, right? I'm not going to tell you how I feel. That part doesn't matter. What matters is that we understand how statistics works. And do we have a good sample, and are we actually including enough people in the conversation? Okay. Now, there's other types of bias as well. There is non-response bias, and this is where individuals who do not respond have different opinions than the ones that do respond. So again, let's say we go out, we find a good sample, we find something that is representative, but we can't force them to answer. So maybe part of the population is not going to answer. Now, we see this a lot because, well, first of all, most nationwide polling is done via phone. And so how many of you are going to pick up your phone for a strange number you don't recognize or answer a text from a number you don't recognize? Okay, if you answered no, then you are not going to be part of any nationwide survey that tells how all Americans feel. Also, a lot of times, if you look at online reviews, there is a huge proportion of online reviews that are either 1 star or 5 stars. And that's because only the people that have really strong feelings typically leave reviews. Right? If you say, watch a movie, and you're just like, meh, that was okay, it's not very likely that you're going to take the time to write a review about a movie you thought was just okay, right? Now, on the other hand, we also have response bias. And this is where we actually do get individuals to answer our survey and give us answers, but their answers are inaccurate to what's actually going on. And this happens for a lot of reasons too. The first of which is just the question is confusing. Researchers spend a lot of time carefully constructing their questions so that hopefully there's no bias in the question itself. There's no leading in the question. There's no, trying to force people to answer one way or the other. For example, this would be a bad question if someone says, well, do you support A or are you really stupid? Well, that's not a great question, right? That's leading. So researchers take a lot of time to write very neutral questions, but that also means that they can be very confusing sometimes, and not always do people answer accurately if they don't understand the question. This also happens when people overestimate their ability. We see all the time that there are some people who believe that they could fight a grizzly bear unarmed and win that. They could not, but they've overestimated their ability. And so again, they answer what they think, but that might not necessarily be the truth. Another one, and this is fairly common as well, if the researcher is asking about either an illegal or a morally questionable activity and the individual is concerned about anonymity, or even if there is anonymity, sometimes we as humans, we're just kind of programmed to give the answer we think people want to hear, or sometimes we're embarrassed. And this happens with a lot of topics as well that are very sensitive. For example, questions about abortion. All right, there's a large population that maybe got an abortion but would not admit to it to some random stranger asking a survey, or about other illegal activities that they might have participated in. And so it's very hard to get an accurate idea of what's actually going on in these cases. And that would be, again, another example of response bias. The last is that, well, we're still all human. It's a human researcher asking a human person, and then that human researcher has to record that data. And there's absolutely plenty and plenty of instances where that data is just entered incorrectly, and there is a mistake with putting that answer in. And then when we go to do those other parts where we organize and summarize and analyze, well, the data is not right to begin with. Okay, now, like I said, there's lots of ways this can go wrong, but we have techniques to hopefully make sure that it goes right. Again, it's important that we recognize that we can never be perfectly sure that our samples match our population, but we do have different ways of making sure that we can do a little bit better. Now, a lot of this is also transparency. Anytime you do a professional study, that methodology has got to be published as well. We need to make sure that everybody knows exactly how you collected your data. That's very, very important. One thing I want to also mention here as well is that when we talk about our sizes, population size is typically a capital N, and sample size is a lowercase n. So just be cognizant when you're doing statistics, and again, this will come up when we start doing formulas as well, that capital N for population, little n for sample size. Now, how do we not get a biased sample? Well, the first one and the most common and the easiest is to do a simple random sample, which is so common that we see the acronym SRS pop up all over the place with statistics. This is where every individual is going to have the same exact chance of being selected. So in this case, let's say I have a population, capital N equals 48. So there's 48 individuals in my population that I want to sample from, which again, we're just making this small so that it looks okay visually. We randomly picked them. So, just out of the group, I picked 6, and those 6 make up my sample size. And I just picked them randomly. There was no rhyme or reason, and there was no pattern to it. Everything was perfectly randomized. And that's the simplest way. But that's not the only way that we do our sampling. The next one is a stratified sample. Now, this is where we take our population and we actually want to separate the population into non-overlapping groups called our strata first. So again, a lot of times we separate the population into either, say, male or female, or we can do by age group. So we can say 18 or younger, and then 19 to 25, and then 26 to 35, and then again, right? We separate these groups so that we have different strata or stratum. So to do stratified sampling, what we do is first we need to figure out what is this characteristic of our population that we can separate by. So again, now in this case, my population is separated into orange and blue. There's two stratum, the orange and blue, and I still want a sample size of 6. So to make sure that each group, the blue and the orange, are equally represented, I'm going to make sure I choose 3 from each of those groups. So I separate them first, then I randomly choose 3 from each one of those groups, and now those 3 form my sample size. And hopefully we can see now that my sample size of 6, each one of these strata or stratum is equally represented, which means hopefully my sample now will have an equal representation of how different proportions of the population feel. And again, a lot of times when we do professional polling, when we poll people, we ask them questions about their demographics like, what is your gender? What is your age? What is your educational background? What are your political views? Those sorts of things. And we include those in that methodology report or the raw data that people use to kind of create their studies. Next type of sampling is a cluster sample. This is where we divide the population into clusters where each of the individuals are kind of located near each other. So first things first, we separate our population. So in this case, I've separated it into 8 different groups. Hopefully we can see with those lines there. And we're going to randomly select one of those clusters, or we could select multiple clusters and combine them into just one sample. So now I picked one of those groups, right? So I have my clusters. I picked one entire cluster. That's now become my sample. Again, my sample size is 6. But notice when we do this, each stratum is not necessarily equally represented because it's all about the groups that are near each other. Now, this is an important type of sampling, and we do see this in a couple different contexts where it is very, very useful. First one is in schools, where, again, a school wants to do a survey about how students feel about a certain topic or try to gain some information or some data. So it's really hard to do a simple random sample and just kind of randomly grab students. So what they do is they assign one class or maybe a couple of classes, and the entire class takes that survey, and then hopefully that picking one class at a time, which again is much easier than trying to randomly pull students, hopefully those individual classes will have a representative view or a non-biased sample of that entire population. This is also very common in quality assurance in production. So if you're going into, let's say, machining, and you are machining ball bearings to be used for the aerospace industry, well, again, you wouldn't necessarily always just kind of randomly pick the ball bearings to test for quality assurance. What's going to happen is, again, they produce them. They are all in boxes. You'll choose one of those boxes that was made and test that one box. And then hopefully that one box represents all the boxes that were produced during that day or so. So cluster sampling absolutely has a place in doing statistics as well. The last type of sampling we're going to talk about is systematic sampling. This is where we kind of arrange the population and then assign every individual a number. Then we select every kth individual for the sample. Now, when I say kth, we use K as our counting number because, you know, K for counting. But anyway, we say kth, and it just means, again, counting using like our counting numbers, our positive integers, so like 1, 2, 3, 4. So maybe we pick every 3rd individual or every 12th individual. And in this case, for this example, I'm going to start at number 3. So again, I have my population is already in order there. I'm going to start at number 3, and I'm going to pick every 8th individual. That means, so count to 8. So 1, I don't want that one. 2, don't want that one. 3, don't want that one. 4, don't want that one. 5, don't want that one. 6, don't want that one. 7, don't want that one. And now 8. Okay, that's the one that I'm going to choose for my sample. And then I'm going to keep doing that. So then I start counting again. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Hopefully we see the pattern. Because I'm going to end up choosing every 8th individual. They now become my sample. And in this case, again, I have a sample of size 6. And this is something that is commonly used in exit polling, where the interviewer is going to ask every 20th person leaving the voting booth who they voted for, because again, that should be somewhat random, but also in a systematic way that can be recorded. We would expect that every 20th person voting, they would have a vote that's independent of the person who was either 20 before or 20 after, right? So again, this is another way that we can introduce a type of system to our sampling to hopefully avoid any bias. Now, again, it's so important that we remember that no matter what type of sampling we use, this is still only part of the data. This is only part of the information. It's only one part of the population. If I were to choose a different sample, I'm going to very likely get different results simply due to the randomness of our universe and the chaotic world that we live in. This is called sampling variability, and it is a part that is baked into statistics and is something we're going to study more when we talk about probability. But we can think for a quick example. If I take the average height of everyone in a statistics class, I'll get a number. And if I go to a biology class across the hall, I'll take everybody's average height. It'll probably be a slightly different number. Now, does that mean statistics classes and biology classes have different heights? Well, no, we just expect that randomness. You're going to get different results when you take a different sample. And so that'll be something we cover when we talk about what would it be if I actually did sample everybody and put that together, and what would that look like? But that's for another day. For now, just remember that every sample has some variability to it. Not every sample is going to be perfectly accurate. We're going to do everything we can to remove that bias. And one of the ways we can do this is that typically the larger our sample is, the more accurate the results are going to be. Again, that's not always the case because we see bias can creep in many different ways, but typically that's just a good rule of thumb. All right, so let's wrap this up. First of all, can you answer the following questions about what does bias mean? And again, there's the bias in statistics, which we need to know first and foremost. And then obviously, what are the contexts that we use the word bias in the real world? And this is going to be just one of the many cases where we take a word from the real world or the outside world and we use it to describe something in mathematics. Usually there is some sort of reasoning that they are similar enough that we can use them. But it's not always going to be the exact same definition, and it's something to be aware of. But I think that's better than the other fields of mathematics where instead of using a word that already exists, they make up their own, because if I told you we were doing a non-homogeneous isomorphism, your brain's probably already shut off, and so it's not always best to create new words. So what does bias mean in all the different contexts? Number two, what are some of the ways a sample can be biased? What are some ways we get bad samples? And again, that's really key to always keep in the back of your mind. How could my sample go wrong? Or how did the other person's sample go wrong? Because that is typically the number one question we should be asking whenever we hear any piece of data or any fact. Number one, who is telling me? And number two, how do they know? How did they get to that conclusion? Then the last one is just, can you describe the different ways we do our sampling? Simple random sampling, stratified sampling, cluster sampling, and systematic. What are the differences between those different methods? All right. Well, I hope we learned something today. I hope we think now a little more carefully about how we grab our samples and we collect our data. And as always, take care of yourselves.